Now what we're going to do is talk about some tools that we have to help us solve equations when they get bigger and harder. Because these were all very basic equations, good ones to start with. But some of our equations are going to look a little harder than that. So there are some properties that we are going to need to know. And they're pretty easy. I don't think you'll have any trouble with them. So I'm going to make a list of 3 properties right here. Well, actually, I'm going to go ahead and list a couple that we already have. We already know that the log base b of b to the p is p. And I really don't remember what letters I used last time. But the idea is if these two numbers match, the answer is the exponent. So these could be x's and j's, whatever, doesn't matter. We also discussed that anytime we take the logarithm of 1, we're going to get 0. These are things that you need to know. These are properties. They're always, always true. Now I'm going to add to this list. We talked about these a few days ago. I'm going to add to this list. The log base b of m plus the log base b of n is the log base b of mn. Now, there's an awful lot of letters there. You have not spent much time in logarithm land. That might look confusing to you. But basically what it's saying is, if you add 2 logarithms, 2 separate logarithms, you can combine them into 1 logarithm by multiplying the numbers. So it's a log plus a log, but that means that the numbers, the m and the n, actually are going to get multiplied. Now remember, every problem we just did in that section only had 1 logarithm. Your goal will always be to get 1 logarithm so that you can do the loop-de-loo that we just talked about. So if your problem has 2 logarithms added together, you're going to combine them by multiplying these 2 things together. Now, if it happens to be a subtraction problem, does anybody want to take a wild guess how I will combine a subtraction problem? Oh, take a guess. If the addition is combined as a multiply, what do you think the subtraction will be combined as?
Negative mn?
Oh, that's a great idea. That's a great idea. It actually is combined as a division. It's combined as a division. So we're going to practice some of these in a minute. Right now, you're just putting down the properties. And there's one more I want to add. If you have a logarithm with a number out in front of it, you can actually move that number to become an exponent. So a coefficient in front of a logarithm is really an exponent. A coefficient in front of a logarithm is really an exponent. Now you have these written down, and I know it's a lot. Let's work through some problems, and I think you'll get the hang of it. Problem A says the log of x minus the log of y, and your job is to write that as 1 logarithm. Write as a single logarithm. So you pay attention. What's going on here? That's a subtraction. So what do I do when I have a subtraction? I turn it into a division.
Does it log x over y?
It is. That's exactly what it is. Yep. So again, the key thing here is we're starting with 2 logarithms, but we're ending up with just 1. So we started with 2 logarithms here, but now we have just 1 by putting these together as a division. Mrs. Ford, why do you do that? because that's my property. These are the rules of the game right here. All right, so let's look at the next one. B says 2 log x plus log y. Now, in order to combine these, which is what we need to do because we need one logarithm, that's our goal, that's the directions, one logarithm. I can't have this 2 here. That 2 can't be there. So who remembers what we said we could do if we had a number in front of a logarithm? What can I do with this number?
Exponent.
It becomes an exponent. So now it's log x squared plus log y. Anytime you have a number in front of a logarithm, pull it up and make it an exponent. So now we have log x squared plus log y. Now I need to combine this into one logarithm, okay? These two are being added. So when I combine them into one, what's going to be happening inside this parentheses? It is not going to be an add. When I combine and add, it becomes a
Multiplication.
yes, thank you. It becomes a multiply. So I have an addition problem, log plus log. I have to combine that into one log. So I'm going to combine the x squared and the y in a multiplication, because that's how I handle the addition of 2 logarithms. All right, let's look at C. I'm going to erase my rules. You've got them down. All right, here we go. 1/3 log z plus log w. David Ortiz, what do you think I'll do first?
You have to get rid of the 1/3, right?
I do. And do you know where it goes?
The other side, do you have to multiply it? Or divide it?
Well, I would if this were already an equation that I were solving, David, that's right. Unfortunately, it's not an equation, it's just an expression. So I need to remember what to do with that 1/3. I want you to look over here at the one we just finished. What did we do with that 2? Where did that 2 show up?
What did you do, multiply it by 2?
Well, I don't really multiply it by 2. It becomes, well, this one became a power of 2. This number is an exponent. So this is going to become the exponent on the z. So it's going to be z to the 1/3. Log z
Mrs.
to the
Smart, we
1/3.
can't hear you.
Uh-oh.
It's like cutting out.
Oh, I don't know. I'm sorry.
Okay.
Can you hear me now?
Yeah.
Okay. I'll try to maybe talk louder or something. I don't know. So z to the 1/3 plus log w. Now, I need to put these two together. My goal is to have the logarithm of one thing. So one logarithm. Notice that's a plus. So when I put these two things together, the z to the 1/3 and the w, will they go together as a times or a divide? Because that's a plus right there.
Multiply.
Yep. So I just multiply z to the 1/3 times w. All right, let's look at the next one. Hang in there, guys. We'll be done shortly. Tell me what the first step is in this problem. They're getting a little bit harder. What's the first step in this problem?
Make exponents.
Yep. So this is going to be the log of xy to the fourth. This gets pulled off and put up here. Minus, whoops, here's one also. So that's going to be log x cubed. So step one is, if you have numbers in front of the logarithm, excuse me, they represent exponents. Okay. Now, Clara Lee, I need to take these two individual logarithms and combine them into one. So I'm going to have the log of one thing. That means I need to combine this guy and this guy. Will I combine them as a multiply or as a divide?
Divide.
Exactly. So I'm going to have x to the fourth, y to the fourth, over x cubed. Now, I hope that didn't confuse anybody. If I am raising xy to the fourth, isn't that x to the fourth and y to the fourth both? And then it's over x cubed. Now, this hasn't happened to us before, but that actually reduces. So I need to reduce this fraction right here. Can you see how that reduces? See how that is going to cancel into that? And all we're going to have left is xy to the fourth. We're going to have one x left and then y to the fourth.
Wait, why does that cancel out?
Because you have x to the fourth over x cubed.
Oh, okay.
We haven't had that yet, but we got to reduce our fractions. Anytime that we can, we reduce. All right, when we finish this section, we'll be done for the day, guys, so we only have a few more to go. Log 4 plus log 7. Now, all our problems up to this point have had letters. Now, these got numbers, which is absolutely fine. We do exactly the same thing. There are no numbers out in front, so we don't have any exponents. So we're just going to jump in and combine these.
Is it log 28?
It is. Perfect. Beautiful. Awesome. How did she get 28? She multiplied 4 and 7. Because our rule says when we're combining an addition, it becomes a multiplication. Nicely done. Well, what about f? It's the log of 16 minus the log of 8. So again, no exponents. It is going to be log 2. And the reason it's log 2 is because we divide 16 and 8. Up here we multiplied because that was a plus. Now we're going to divide because that's a subtract. Don't forget, you still have a log. You're going to take these two and make 1. So it's log 2. Great job. All right, what about G? Anybody got a plan about G? Now, first of all, are you stumped by the LNs? Don't be. We're just going to have 2 LNs. We're going to have 1 LN. LN is just a type of logarithm. If it confuses you, write it as log base E. But these are 2 logarithms. What am I going to do with these numbers? What am I going to do with the 19 and the 8?
Over each other?
Yeah.
Divide.
Yeah, divide. That's exactly right. Have confidence. You're exactly right. Why am I putting them over each other? Because this is a subtraction. And that's what I do when I have a subtraction. 19 over 8 doesn't reduce, so I'll just leave it as 19 over 8.
Could you do it as log E 19 over 8?
Uh-huh. Yep. Sure can. Anytime you see ln, you can write it as log base e. You never have to, but you always may. All right, one more, and then we'll be done for the day. Now be careful here. I know you see this plus, and I know you're thinking multiply. But wait, you got to do something else first. What do we have to do first?
Move the numbers out in front.
Exactly. Anytime you have numbers out in front, you have to make them exponents. So this is going to be ln 2 cubed. There comes the exponent. Plus ln 36 to the 1/2. I'm not multiplying, those are powers. This is 36 to the 1/2. This is 2 to the 3rd. Now let's clean them up. What's 2 to the 3rd?
8.
Yep. Uh-oh, this one's a little harder. What's 36 to the 1/2?
6.
Yes, perfect. For those of you that don't get it, this is a radical. So it's a square root of 36 to the 1st. The square root of 36 is 6 to the 1st is 6. Very nicely done. Now, one more step. We got to put them together. We have a log plus a log.
So it would be 48.
So it'd be ln 48. Don't forget the ln. You're combining the 2 logarithms into 1 logarithm. So don't forget that it's going to be an ln answer, ln 48. Now, next time we're together, which will be Friday, we're going to do the opposite. So we're going to take things that are already together and we're going to pull them apart. But that's going to wait until Friday. We're going to stop now. Okay? Everybody clear on Friday's change of plan? So we have class on Friday, so I need you to come. They're short classes, but we'll get through this next section. Okay?
Thank you.
Thanks for checking in today. You guys have a good day. Flex it too. All right, bye-bye. Let's turn that off.